So today I'm going to give you a little preview of what's to come in both chapters 6 and 7. And the reason that we're going to handle them both simultaneously, that means at the same time, is because they're so connected that I think your understanding will be better if we do them hand in hand. So chapter 6 is all about adding fractions. And what do you think chapter 7 is about? Exactly, subtracting fractions. And we are very comfortable toggling between the two. And the more comfortable we get, understanding that they're really the same operation, except exact opposites of each other, the more connections we'll make, and it will be easier as we continue into 6th grade math and beyond. So we're going to handle chapters 6 and 7 together and talk about adding and subtracting fractions. So I have this diagram here of 2 pizzas. The pepperoni pizza is cut into 6 slices, and the veggie pizza is cut into 10 slices. And I want you to just kind of talk about maybe some problems we might run into if I were trying to describe how much pizza I ate last night. So if I said, well, I had 2 slices of pizza, what questions might you still have, though, about the pizza that I ate? Looking at these pictures, you're probably thinking about some, yes?
Excuse me, teachers, please place recycling in your hallways.
Okay. Someone want to drag that out in the hallway? Thank you. Thanks, Travis. What questions might you have, Leah? Did you come up with a question?
How big the slice was?
Okay, so she's looking at these different pizzas and she's like, wait a minute. If she said she had 2 slices of the pepperoni, that would be a lot bigger than having 2 slices of the veggie one, right? So size matters when we're talking about the number of pieces. So would you say that these 2 pizzas are equal in size?
Yeah.
Right, but the number of cuts in each pizza is different. And we can represent that in fractional amounts, right? So think about the denominator involved with this pizza. How many parts is this pizza cut into? 6. That's kind of a small number. How many pieces is this pizza cut into? 10. And the denominator is bigger. So can we kind of wrap our minds around this rule that if the denominator is a small number, the pieces are bigger. And if the denominator is a big number, then the pieces are smaller. Why? Because what does the denominator do? It represents the whole pizza, the whole group. And the more you cut it, the smaller those pieces are going to get, right? So kind of like our classroom too, if you think about it as a set instead of a whole object, our class is a whole group, right? And when we have every member here, we have a whole class. But when we have some people absent, then parts of the whole are being taken away from the group, right? So here are some vocabulary terms that we're going to need to use this chapter and be very comfortable with their meaning. Now, some of them you probably already have heard before and know how to describe, but let's just recall a couple. So fraction, if I had to define the word fraction, it's really a division problem. It represents parts of a whole. A fraction has 2 parts to it, right? It has a numerator and a denominator. And we can see that on this next slide here. The numerator is on the top, and it shows the number of parts that we have. And the dividing line represents the division involved. That's the operation. And the denominator shows what amount of parts represent a whole. So what amount of parts are equally shared among the group? If we go back to this vocabulary list here, we see that mixed number. Has anyone heard of a mixed number before? Alan, what have you heard? What's a mixed number? It's a number that does contain a fraction, and what else? What's that big number called? Do you know? It's just a regular whole number, right? So you have a whole number and a fraction together. That's when it's called a mixed number. Have you seen maybe on a recipe before when maybe your recipe calls for, let's see if I can annotate on here. It'll call for, exactly, it'll say you need 2.5 cups of flour, something like that. That's a mixed number. It contains a whole number plus a fractional amount that together represent that value or quantity. Equivalent fractions, we dealt with this in the last chapter when we dealt with common denominators and things like that. This list over here on the right, these are equivalent fractions. What's equivalent mean? What was that prefix equa mean? Mackenzie, what's that prefix mean? It means equal, that's right. So equivalent means that they're equal in value. They might not look the same, right? Their shape might be different. How many slices they're cut into might be different. But would you look at these little circles up here that represent a half of a pizza?
Yeah.
They're all the same value. They all have the same amount of pizza left, but what has changed? The way that they look, right? The amount of cuts in each pizza. So equivalent fractions, their value doesn't change, but the way they look changes as you adjust that numerator or denominator. We're going to practice that a little bit more today. Easiest common denominator and lowest or least common denominator are things we're going to be continuing to build strength with. And this term might be new to you down here. These are verbs. These are action words. They mean to do something. So reduce and simplify means to remove or get rid of common factors between the numerators and the denominators. And that's a skill that we will continue to practice as we go. But those are just some things to expect during this chapter. Okay. Let me see if I can get to the next. Yeah.
I don't remember learning easiest combination.
That's something that will be easier to teach you when we have fractions in front of us. So we're going to talk about easiest common denominator. So I've already taught you lowest common denominator, least common denominator, and the easiest isn't the first occurrence. It's just the one that is the product of the two denominators. And it will be easier to understand when we have a couple of examples in front of us this week, okay? So here's just a model to help you understand equivalent fractions and how they go about being equal in value but different in size in the way that they're shaped. And we have some equivalent fraction practice. I'm going to pass this out right now. And then I'm just going to draw on the screen here and fill in the missing spots along with you. I'm going to do the first 4, and then you have the rest of the page to do. I'll give you about 5 minutes. Shouldn't take you longer than that. But just to recall, what our technique is when we're making equivalent fractions, either we can make up our own by picking a common factor, like pick a factor, like some silly number, like maybe 100, right? 100. So if I multiply the top times 100 and the bottom times 100, I'm going to get an equivalent fraction. Excuse my horrible mouse writing. I'm going to get an equivalent fraction to the original base fraction, right? That has the same value. It just is a different shape and size. What factor did I use to compose that new fraction? What factor did I use? What factor, class? 100, right? So look at what factor did I use to get from 2 to 4 though? What factor? 2, right? So I would use that same factor on the bottom as well. What would I place in the denominator section on this fraction? 14, yep. And so you use that same idea to go through all of the equivalent fractions, and you might see some patterning picking up here. You might see some patterning, but you can always go back to the base fraction and say, well, how do I get there? That's a factor of 3. So I use that factor of 3 again on the denominator, right? You go to the next one and say, how did I get there? How did I get to 8 from 2? Factor of 4. So I use that same factor of 4 on the denominator, and that's 28. Are you starting to see a pattern on this first one? Look at this pattern. 2. It looks like you're not always using a factor of 4. Look at this one was a 2. This one was a 3. This one was a 4. What do you think the next factor team is going to be? A 5, right? So 7 times 5 is 35. 2 times 5 is 10. Wow, that was a bad 10. Let me try you again. Could we infinitely come up with equivalent fractions? Forever and ever and ever and ever and ever. Yes. This worksheet just happens to take you through the first 8. So it'll go take this base fraction, multiply it times a factor of 2, times 3, times 4, times 5, times 6, times 7, times 8, okay? And we'll do that for each one. So let me pause the recording and then I will be back to fill in the rest here with you momentarily. Okay, so I'm going to use my pen now. Maybe I will have better success with my drawing, right? So if I fill in just all of those, hi, come on in.
Mind if I interrupt for a second?
Go right ahead.
Morning, boys and girls.
We have a recording going too.
Oh, do you? Oh.
No
Am I
one's
talking
there.
to-
No
oh, no
one's
one's
there
there.
on the other end
Okay.
just yet, but I'm going to be uploading it later.
Uploading it later.
Just a disclaimer that your
Oh,
words are.
I'm being
Father
recorded.
David, everyone.
I gotta watch. I gotta watch what I say, huh? Good. You guys doing well?
Yes.
You look like you're in the thick of what is this? Fractions.
Mhm.
Nice. Oh,
Equivalent fraction.
equivalent fractions. Very cool. Good, good. You enjoy math, you guys? Good. Well, you got a good teacher, so that helps, right?
Did you do a math magic trick on Friday?
Oh,
Yeah,
yeah.
Ooh.
that was fun.
Nice.
With sequencing and
Oh, okay.
probability.
Very cool.
I don't have time for that
We don't have time
today,
for that. I
but
just
you'll
wanted to
have
say hi. I hope you enjoyed. You had a day off yesterday, huh? Good, good, good. Well, it's good to see you guys. I won't interrupt the recording anymore,
That's
but
Thanks for
good.
stopping
All right.
by.
God bless you.
Thank
Take
you.
care.
So that last guy, what did we think about that last piece? Ella, what did you get there? 49. How did you get that?
I did 7 times.
What factor helped you get there? 7 times. Oh. Turn off that.
7 times 7.
7 times 7. Okay, so 7 times 7 and 2 times 7 will get you up there, right? So the factor is 7. So the only way to make it take the same value as that original base fraction 2/7 is to multiply it times the same factor. And that was 7. So each of these you'll notice his factor is 2, then 3, then 4, then 5, then 6, then 7. 2, then 3, then 4, then 5, then 6, then 7. And that allows you to see a pattern kind of taking shape. So for this next one, if I went from a factor of 1 to a factor of 2, what would the bottom number be that correlates with that, Ryan?
10.
10, you got it. So it looks like, do you see this pattern developing right here? Right? So those equivalent fractions are all in order. And so it's nice that you can pick up on a pattern. Once you see a pattern developing, then you can just run with it, right? Did you see that pattern for number 2 developing? How about for number 3? Do you, once we get going, let's try the first one and get going. How did I get from 3 to 6? That's a factor of 2. So if I use that same factor of 2 to the numerator, I end up with a factor or a numerator of 4. And I can see a pattern developing here. Do you? 2, 4, 6,
8,
8, 10, 12, 14. Hey, I've got it. Now look at the bottom though. Here's the pattern developing. 3, 6, 9, 12, 15, 18. Use your multiplication charts to help you. Okay, let's do one more here. How would I get from a factor or from this denominator 4 to 8? What factor do I need to make it work? A 2. So let's use that same factor on the top. 3 times 2 gives you, come on everyone, 6, thank you. All right, do we see a pattern developing on the bottom at least in the denominators? 4, 8, 12, 16, you got it. Now, will I always have equivalent fractions in increasing order like this, really nice and easy? No, but it is nice to recognize that you can make equivalent fractions in this fashion. Okay, so I'm going to give you a minute to finish the rest of this page, pick up on those patterns, and then for the rest of our class period, you're going to be able to just use some of our time here to get a head start on your freckle minutes. So there will not be any other assignment after you finish this part, okay?
Yeah. You can keep it.